College Trigonometry, Chapter 10, Section 1, the Law of Sines. In Chapter 8, we found that if we have enough information about the sides and the angles of a right triangle, we can solve for the parts that are missing. If you have a right triangle, you have to know at least one side and one acute angle, or two sides. You already know the 90-degree angle, so the fact that you have one angle already is given to you. In this chapter, we're going to learn how to find the missing side and angle measures for any type of triangle. What we need is we have to have 3 of the 6 measurements. Triangles have 6 measurements, 3 sides and 3 angles. We need to have at least 3 of those measurements, and at least one of them needs to be a side. Now, these are the congruence axioms that you had in geometry. I'm just going to go ahead and put them all up here. You had side angle side, which said that if 2 sides in the included angle of one triangle are equal to the 2 sides in included angle of a second, they're congruent. Angle side angle, so it's basically the same thing, but it's 2 angles in the included side. And then side 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 said if 3 sides of one triangle are equal to 3 sides of a second, the triangles are congruent. Now, why do we bring these up? Well, the fact that we can use them to prove triangles congruent means we can also use them as being sufficient information to find the remaining sides and angles of the triangle that we have. In other words, if we know 2 sides and the angle in between, we know that we have a unique triangle that we can find the remaining parts for. The same for angle, side angle, and side, side, side. So these 3 will have sufficient information. Now, when we're solving oblique triangles, there's some different cases we have to consider. One is if we know one side and 2 angles, and the side can either be in the middle or not. If we know one side and 2 angles, then we're good to go. We can use the laws that we're going to be talking about in this section and the next, and we can find the remaining sides and angles that are missing. So 2 angles and a side, no problem. Case 2 is a little different. Case 2 says we know 2 sides and we know an angle, but the angle's not in between those 2 sides. This would be SSA. Or if you remember from geometry, you're always told never use angle side side. That doesn't work, and you don't want to write the abbreviation down. It's just kind of a way to remember not to use that. The reason we can't use it is because it doesn't necessarily guarantee that the 2 triangles are indeed congruent, and we're going to see that. Now, that doesn't mean you can't solve the remaining measurements of a triangle if you have 2 sides and the angle not in between. However, it's a little tricky because it could be that you don't actually have a triangle, or that you have one unique triangle, or that you have 2 triangles. And when you have 2 triangles, you have to actually figure out all the measurements for both. This is called the ambiguous case, and again, that's why you can't use it to prove 2 triangles congruent. In case 3, we know 2 sides and the angle in between, and if we know that, we're good to go. That's our side angle side. And finally, 3 sides are known, we're good to go. We can figure out the angles using the laws that we're going to talk about. So first law we're going to talk about is the law of sines. The one we'll talk about in the next section is the law of cosines. The law of sines is in any triangle ABC with sides ABC. Side A over sine A equals side B over the sine of angle B equals the sine C measurement over the sine of angle C. You can also flip all of that upside down and use that. Now, when we solve for missing parts with this, what you want to do is actually use 2 of the fractions. One of them has to have all of the information, and the other needs to be missing either the angle or the side. A little hint, if you write it so that what you're missing is on the top, it actually makes your work easier. So if you're missing a side, and that's what you're looking for, then you probably want to use the top ratios. If you're looking for an angle, then using the bottom set will be much easier. We're going to solve triangle ABC if A is 32 degrees, B is 81.8, and side A is 42.9. Now, you can figure out angle C because you know the angles of a triangle have to total 180. So find angle C and then find side A and side B and side C using the law of sines. Pause the recording, give it a try, and resume to check your answer. It's always a good idea to sketch and given this sketch here is a pretty good sketch. The sketch that you draw is probably not going to be accurate. Mine certainly aren't, because you're just kind of putting the numbers on there. You don't know what you're missing. A sketch of a triangle is really for placement only. Notice how it's labeled. You use the capital letters A, B, and C for the angles, and the sides opposite those angles are labeled with the matching lowercase letter. Put in the values that you know, and then we can see that we need to find side B. We're finding side B first, so we set up the ratio to do that. And by the way, don't forget you need to be in degree mode for this, and we get that B is 80.1. We can find angle C using the fact the angles have to total 180 and get 66.2 degrees, and then use the ratios to find side C. Notice we went back to A over sine A. The reason for that is that those were values that were given to us, and so we're not having to use approximations. We didn't have to round anything, so that's going to give us a little more accurate answer. Here's an application problem using the law of sines. Read over this, pause the recording, give it a try, and resume to check your answer. Okay, all you had to do for this one, you did need to find angle B in order to solve it, so that you have angle B and side B both. And then the only thing you need to find is A of sines. And we'll solve for the variable, and we get that it's 305.5 feet. Here's another application problem. Now, if you didn't get bearing down the first time we went over it back in chapter 8, then you need to review that and get it down now, because bearing is going to come back into play in a couple of sections in this chapter. Read over this problem, make a sketch, solve it, and then resume the recording to check your answer. So you see from the drawing, remember, bearing, what you want to do is you want to draw a line to the north, pointing north, and then 42 north, 42 east means from north, you're going to rotate to the east 42 degrees. And then the same for the 15, you see those there. Look how everything is labeled. Okay, we know that angle A of that triangle has to be 90 minus 42 because north, south, and east, west meet at right angles. And we know that angle B of that triangle has to be 90 plus 15 degrees, which is 105. Then use the law of sines, and you find that B is 234 miles. Now let's talk about the ambiguous case. If we're given the lengths of two sides and the angle opposite to one of them, side-side angle, then you can have either 0, 1, or 2 triangles formed. Let's say we know the measurement of acute angle A for triangle ABC, as you see here, and we know the length of side A, and we know the length of side B. So we got to draw in A, but we need to make it make a triangle here. We need to match it up so it makes a triangle. Now, imagine A, the length of side A coming down from C in this picture. You know, where is it going to fit? Well, let's look at some possibilities. The first possibility is when we have no triangles, and the problem is that A is not long enough to reach down to side C. No matter what you do, it's not going to touch that side anywhere. And in that case, we don't have a triangle. It could be that A goes straight down and makes a right angle with side C. So angle B is a right angle, in which case we have 1. It could be that A is long enough, matches up, and we have 1 triangle there, as you see in the third box. And the fourth one, it could be that A is the exact right length where it could actually meet up with that side in 2 spots, in which case we have 2 triangles. Now notice in all of these cases, angle A, the angle we're given, is acute. So if it's an acute angle that we're given, we could have 0, 1, or 2 triangles. And we'll talk about how to figure that out, so don't stress over that. Now what if A is obtuse? Where there's 2 possibilities. Either it won't work, as in the first sketch, or it will work, and you'll have 1 triangle, as in the second sketch. So only 2 possibilities there. All right, so let's talk about this. Let's let sides A and B and angle A be given in triangle ABC. How do we know which of these different instances we have. Well, what you're going to do is you're going to go ahead and solve for that missing angle. Solve for the angle across from the given side. And if when you solve it, you get that the sine of that angle is greater than 1, well, the sine of an angle can't be greater than 1, which means there is no triangle. It does not exist. If you're putting it into your calculator, when you do the inverse sine of whatever that is, it'll come up with an error message. It'll say error domain, which means that there is no sine, there is no angle that has that sine, and that tells you have no triangle. If, when you to solve for the angle, if the sine is 1, then you have one triangle, and it's going to be a 90-degree angle that you have. Now, what if it's not greater than 1 or 1? It's going to be between 0 and 1. Then you could have one or two triangles. How do you know? Well, take the sine of b, get your angle. And when you get your angle, you get b, that's going to be the angle in the first triangle. Then you want to check to see, is there potentially a second triangle? So what you do is you take what you found in part A here, you get that angle B, you subtract it from 180. Then you add that result to angle A, to the angle they gave you. If that's less than 180, then you do have a second triangle. And the what you got when you subtracted your result from part A from 180, that is going to be the angle for B in the second triangle. It makes a little more sense. It's a little easier when you actually do it. If you add them together and it's greater than 180, then you don't have a second triangle, and you just go ahead and do the one triangle. All right. Now, the slides, as we go through them, they're going to tell you, okay, this is one with no triangle, this is one with 1, this is one with 2. Remember that in your homework, it's not going to be labeled like that. So you do need to remember how to figure out what you've got. But the remaining few problems before we hit the additional practice are going to be the ambiguous case, so you know that. Pause the recording, give this a try, and resume to check your answer. Okay, so when you try to solve for the missing angle, the one you can solve for, which in this case is actually angle A. Remember, the letters, we got to give them letters. It's more of a case of, you're looking for the angle that's opposite the given side, the angle you don't know. When we do that, we get that the sine is 2.3. Well, that's greater than 1. So that tells me that there is no triangle. So this one is solution. Now try this one. Pause the recording, give it a try, and resume to check your answer. Okay, so when we solve this one, we get that B is about 63.9 degrees. Well, subtract that from 180 and we get 116.1. No. And by the way, once you find 63.9, you go ahead and use that and solve for side C and angle C, solve for everything else. But now we see that when we subtract from 180, we get 116.1. Now, this may or may not indicate a second triangle, but if we add that to angle A, we discover that there is indeed going to be a second triangle because the result's less than 180. So we're going to have the 116.1 is going to be our B2, which means our C for our second triangle is going to be 8.6. And then again, we use the law of sines to solve for that. And now let's try one more problem. Pause the recording, give it a try, and resume to check your answer. Okay, so we get 27.6 degrees for C. 180 minus 27.6 is 152.4. Well, if we add that to angle A, we get 195. So it's greater than 180. That means there's only one triangle. And then you solve for the rest of the missing measurements on that triangle. All right, the rest of this video is going to be additional practice. So pause the recording, give them a try, and resume to check your answer.